Hi everyone, my name is Narbi Kocharians and I'm here to talk about Ospf area types. So let's get going. So let's say we have area 0 and in this area we're advertising 100 routes. So that means that if I go to a given router within area 0 and I do a show IP route Ospf, I'm going to see, let's put area 0 here. I'm going to see 100 O routes. These are intra-area routes. So let's write intra-area here. So now let's add area 1 to area 0. So I'm going to have an ABR here. And I'm going to connect area 1 to area 0. Area 1 is also advertising 100 routes. So if I go back to the same router in area 0, and now I do a show IP route Ospf, I'm going to see my own routes as intra-area routes, and I'm going to see 100 routes as IA or inter-area routes. These are routes coming from area 1. You see, traffic from an area's perspective can be intra-area traffic or inter-area traffic, or the traffic could be external. If the traffic is intra-area traffic, this is traffic within our area. If the traffic is inter-area traffic, this is traffic entering my area from another area within the same routing domain. But if the traffic is external, it means that traffic was redistributed. This is traffic from another routing domain that we have redistributed into our Ospf routing domain. So now let's add areas 2, 3, 4, and 5. We're going to put an ABR here. We're going to add area 2, another ABR, so we can add area 3, and this is area 4, and of course area 5. These areas are also advertising 100 routes. So now if I go back to the router in area 0 and I do a show IP route Ospf, I'm going to see my own routes. These are 100 routes. These are intra-area routes. Now I'm going to see 100 routes coming from area 1, 100 routes coming from area 2, another 100 from area 3, another 100 from area 4, another one from area 5. So that means 100, 200, 300, 400. I'm going to see 500 IA routes. So now let's add some ASBRs. I'm going to add 4 ASBRs. I'm going to add an ASBR in area 3, one in area 4, third one to area 5, and the final one, or the last one, to area 0. So I have an ASBR. And this ASBR is redistributing 100 routes. This arrow means that I'm redistributing 100 routes into my Ospf routing domain. Same thing over here. And this ASBR is also redistributing 100 routes. So my third ASBR is also redistributing 100 routes. But the ASBR in area 0, he is redistributing 500 routes. So now if I go back to the router in area 0 and I do a show IP route Ospf, I'm going to see my own routes as intra-area routes. I'm going to see 500 routes coming from other areas. These are inter-area routes. Now I'm going to see 100 over here, external routes, plus 100 is 200. 300 plus 500, I'm going to see 800 external routes. By default, they will show up as E2. Total number of routes, 1,400 routes. So the administrator of Area 1 gives you a call. He says, Narvik, 1,400 routes are too many routes. Can you do something to reduce the size of our link state database? Of course we can. But before we configure Area 1, the question is, do they like to see the inter-area routes, these are routes coming from the other areas, in their routing table? And he says, yes, I definitely need to see the inter-area routes in my routing table. So in this case, what I can do is, I can configure Area 1 as a stub area. So let's do this. We're going to say this area is going to be stub. And I'm going to go to the ABR, and I'm going to say Area 1 stub. Now this entire command needs to be repeated on every router within Area 1. So the area stub flag matches. So I'm going to go on all routers. And I'm going to do Area 1 stub. So now let's see what LSAs I'm allowed to propagate within Area 1 and what LSAs are going to be blocked. So the ones that I'm allowed to have, I'm going to put them in blue. The ones that I'm going to block, I'm going to put them in red. So here, I can have my own LSAs. These are intra-area routes, type 1s and type 2s. Type 3s are routes coming from the other areas, plus a default route. Who injects that default route? The ABR injects that default route. And he injects that default route as LSA type 3. So now let's see what LSAs are blocked. Who blocks these LSAs? The ABR does that. He's going to block LSAs 4s and 5s. So basically he blocks LSA 5s. If LSA 5s are blocked and LSA 4s provide reachability to the ASBR, then it's useless to have LSA type 4s when I cannot have an ASBR or type 5 LSAs in my area. So for that reason, 4s and 5s are blocked. So now let's go to a router in Area 1 and do show IP route Ospf and see how that affected our routing table. So I'm going to go to Area 1. And I'm going to do a show IP route Ospf. I'm going to see my own 100 routes. These are LSA 1s and 2s. I see the inter-area routes. These are 500 routes coming from other areas. And I'm also going to see a default route. The default route is injected as IA. Total number of routes is 601. And this is what makes Ospf so scalable. So now the administrator of Area 2 gives you a call. And he says, if you're giving them, or if you're going to give us a default route, like you did in Area 1, can we not use that default route to reach inter-area routes? Of course they can. They can use the default route to reach any destination that is not in their routing table. So he says, can you block inter-area routes? Sure we can. How do we do this? What we're going to do is we're going to go to the ABR, and I'm going to say Area 2 stub no dash summary. Now, this portion of the command needs to be repeated on every single router within Area 2. So on all routers, we're going to say area 2 stub. Now, what LSAs am I allowed to propagate in area 2? I can have my own LSAs, 1s and 2s. Now I can no longer have LSA type 3s because I'm blocking them. Who's blocking them? The ABR is going to block LSA type 3s. Now, whenever LSA type 3s are blocked, the ABR has no choice but to inject a default route. So in this case, he's going to inject a default route. The default route is injected as LSA type 3. You see, the ones that we're blocking are routes coming from the other areas. Even though the default route shows up as LSA type 3, this is not coming from another area. This is originated by ABR for area 2. And this is why I'm allowed to have a single LSA type 3 that's originated by ABR, and that propagates the default route into that area. So what LSAs are blocked by the ABR? 3s, 4s, and 5s. So now let's go to a router in area 2 and do a show IP route Ospf and see how that affected my routing table. So I'm going to go to area 3, or area 2, sorry. I'm going to see my own 100 routes. These are 1s and 2s. And I see a default route, and the default route is injected as IA. Total number of routes, 101 routes. Now, this is called totally stubby. Totally stubby. Now, why is it totally stubby? Because we cannot have LSA type 3s. The administrator of area 3 gives you a call, obviously with a similar problem. Now, when you look at area 3, you realize that they have an ASBR. So these guys want to be stubby, but they don't want to be that stubby not to have an ASBR. So what do we call them? Not so stubby. So now we're going to configure area 3 as not so stubby area. How do we do this? We're going to go to the ABR. We're going to say area 3 NSSA, and we're going to repeat this entire command on all routers within area 3. So I'm going to go on all routers. I'm going to say area 3 NSSA. So what LSAs am I allowed to propagate within area 3 here? I can have 1s and 2s. You see, I'm not blocking 3s like I did in a totally stubby area. So I can have 3s. I have an ASBR, and this ASBR is redistributing 100 routes, and those routes will show up as LSA type 7s. And that's all I'm going to have. You see, in a regular, not so stubby area, the ABR does not inject a default route. The assumption is that one of the routes that the ASBR is redistributing happens to be a default route. So if the ASBR is injecting a default route, and the ABR is also injecting a default route, you're going to go this way to connect to a given destination. So what LSAs are blocked over here? We're going to block 4s and 5s. So now let's see how that affected the routing table in area 3. So I'm going to go to area 3. I'm going to do a show IP route Ospf. I'm going to see my own 100 routes. These are intra-area routes. I see LSA type 3s. These are 500 IA routes. These are inter-area routes. I see type 7s. These are the routes that the ASBR is redistributing into that routing domain, into this routing domain. So that's 100 by default N2 routes and these are external. Total number of routes, 700 routes. You know what? We forgot to write that these are intra-area routes and these are inter-area routes. So the administrator of Area 4 gives you a call. Obviously, you're receiving a lot of phone calls these days. And obviously has identical problems. So in this case, the administrator says that they need to reach the external routes that are redistributed in other areas within our routing domain. Basically, what they're asking for is a default route. Notice in a regular NSSA area, the ABR does not inject a default route. But obviously, these guys want to have a default route. So in this case, what I'm going to do is, I'm going to configure the ABR by saying Area 4 NSSA default information originate. Now, this portion of the command needs to be repeated on every single router within Area 4. So let's go on all routers. We're going to say Area 4 NSSA. Now let's see what LSAs are propagated in Area 4. So here we can have type 1s, type 2s. We haven't blocked LSA type 3s, so we're going to have 3s. We have an ASBR that's redistributing 100 routes. Those will show up as type 7s. The only difference between the two areas, Area 3 and Area 4, is the fact that the ABR is now going to inject a default route. Now, since we used default information originate, the default route will be injected as external routes. In this case, it'll be injected as N2. So we're going to have a default route. What LSAs are blocked? 4s and 5s. So now let's go to a router in Area 4 and do a show IP route Ospf and see how that affected our routing table. So in Area 4, we're going to do a show IP route. I'm going to see my own routes as 1s and 2s as intra-area routes. I see LSA type 3s. These are 500 routes showing up as IA. These are inter-area routes. I see type 7s. These are the 100 routes that their own ASBR is redistributing into Ospf routing domain. So they're going to see 100 by default as N2. I'm also going to see a single default route that's injected by the ABR. This default route will show up as N2. So total number of routes, 701 route. The administrator of Area 5 is having an identical similar problem, but he sees what we've done for Area 4, and he says, you know what, if you're going to give us a default route, can we not use that default route to reach inter-area routes? It's kind of similar to Area 2 here. Of course they can. So we know that the minute we say no dice summary, the ABR will inject a default route, and we cannot stop that. So in reality, I don't have to say no summary, default information originate, because by saying no summary, the ABR is going to inject the default route anyway. So now what we're going to do is we're going to go to ABR, and we're going to say Area 5 NSSA no dice summary. Now, this portion of the command needs to be repeated on all routers within Area 5. So I'm going to go on all routers within Area 5, and I'm going to say Area 5 NSSA. Now, what LSAs are we propagating over here? We're going to have LSAs 1s and 2s. We're blocking 3s, so we cannot have 3s, but we can have 7s plus a default route. What LSAs are being blocked by the ABR? 3s, 4s, and 5s. You see, 4s and 5s are always blocked. 3s are only blocked when we say no summary. And the minute we say no summary, the ABR will inject a default route. If you notice, in area 2, we said no summary, and the default route was injected by ABR as LSA type 3. The same thing happens over here in area 5. The minute we say no dash summary, the ABR is going to inject a default route as IA. So let's see what happened to the routing table in area 5. So in area 5, we're going to do show IP route OSPF. We're going to see our own 100 routes as intra-area routes. We don't see LSA type 3s, but we see LSA type 7s. These are 100 routes. By default, they show up as N2. And we see a default route here. The default route is injected as IA. Total number of routes, 201 routes. Now, what if our ABR in area 3 redistributes a loopback interface, or redistributes a whole bunch of routes from another routing domain? So let's say here, I'm going to put a loopback, configure a loopback on that ABR, and I'm going to redistribute that loopback into OSPF routing domain. That loopback will show up in area 0 as external type 2, and it'll show up in area 3 as N2. But what if I wanted to redistribute the route such that only the routers in area 0 could see the route? Meaning what? Meaning that I don't want any router within area 3 to see the redistributed routes. So here we have our ABR. Our ABR happens to be an ASBR, and any route that he redistributes should not be redistributed in area 3. They should only go into area 0. In this case, all we need to do is just say no redistribution. Once we say no redistribution, the routes will not be redistributed into area 3. They'll only be redistributed into area 0. So now let's talk a little bit about why do I need to repeat this command on all routers in areas 1 and 2. Now, in OSPF, 2 routers will use hello messages to form an adjacency. If I look at those hello messages in Wireshark or Sniffer, in the options field, I'm going to see the EBIT set. When I configure these areas as Stub, the hello messages that these ABRs are sending or are generating will have their EBIT cleared. Why is the EBIT cleared? Because we don't have external routing capability. So if I cannot have external route capability in these areas, it's useless to set the EBIT in the hello messages. But the router to which these ABRs are directly connected to, by default, they don't have the EBIT cleared. So if they don't have the EBIT cleared, when they receive a hello message from the ABR, they're going to discard that hello message. If they discard 4 hello messages in a row, the adjacency is torn down. So this is why we need to repeat that command on all routers within that area. When it comes to not so stubby area, instead of EBIT, the ABR sets the N bit. Obviously, if the N bit is not set on the router to which I'm directly connected to, he's going to tear down the adjacency in the same manner. The last item that I wanted to cover over here is how can we utilize the default route that is injected by the ABR. Now, over here in area 4, the default route is injected as external. In area 5, the default route is injected as IA. Now, how can we utilize that to our benefit? So let's say I have an ABR here, ABR1. He has a connection to routers in area 0, and he has another connection to area 1. I've configured this ABR as area 1, NSSA, no dice summary. Now, what routes is he going to inject into area 1? If I say no dice summary, LSA type 3s are not going to be in my area 1. Instead, I'm going to get a default route, and the default route shows up as IA. So let's say we have another ABR here, ABR2. Now, this ABR is configured as area 1, NSSA, default information originate. Now, since I said default information originate, the ABR is going to originate a default route, but in this case, the default route will show up as N2. But since we're not blocking LSA type 3s, he's also going to give me individual LSA type 3s. So now let's assume that you are a router in area 1 over here. If you're a router in area 1, and you need to connect to the individual LSA type 3s, you're going to go this way. Why? Because he's the one that gives you the individual, the specific routes coming from the other areas. But for any other route, you're going to go this way. Why? Because in Ospf, IA routes are preferred over external ones. So you see, by utilizing these two commands, we have achieved some type of a load sharing capability over here. Now, this is it for area types. In the future OSPF lectures, I'm going to go a little bit deeper into the bits and bytes, into p-bit and the other bits, and we're going to talk about authentication and other features of OSPF. Thanks for listening.